we're talking about real numbers, and before we even start classifying them, let's get a good idea of where our real number system came from. So this is 3-10, the real numbers. Robert. And our real number system comes from, you know, when we're about like 3 or 4, we really get introduced to some real good TV shows. Make sure that your notes are out and that you're taking notes. Mr. Jack. Guys, we get introduced to something like Sesame Street, and that show we learn to count through 1 through probably 10. So 1, 2, 3. Brendan, you got a question, buddy? Okay, thank you. You probably learned to count all the way up to 10, and we call these our counting or our natural numbers because, 1, we're learning to count. So let me change this. I'm going to put a box around this, guys, just so we really know that our counting numbers, we're learning to count. And then move on from there because, you know, you get a little bit sophisticated as you grow up and you move on to a show from Sesame Street, you move on to Barney or something, and now you start counting. Say, there is more to life than just 1 through 10. I'm more sophisticated. And the real shocker is that you learn there's this value of 0. You had some, but now you have none. So now you start counting 0, 1, 2, 3, 4, I love you, you love me, Barney. And you move on. You probably can count all the, this is not a 9, by the way, it's a 4. Probably move all the way up to 20 or something, but then you come to a stop. And we actually call these numbers, our whole numbers. And our whole numbers, what they really do is they take our counting numbers, our 1 through 10 and so on, all of these positive numbers that start at 1 and move forward, and they say, hey, we're going to add 0 to it, and that is our whole number system. So what I'm really doing, I'll just write it to the side real quick, taking my counting numbers and adding 0. These become my whole numbers, Grayson. Let's box this one up now. Hey guys, I think y'all can see up here, since 1 through 4 and so on are on here, are counting numbers including with whole numbers here? Grayson, could you tell me, are the counting numbers included with the whole number 0 here? Yeah, absolutely. So what we say is we're going to put a box around everything here, and the counting numbers are a part of the whole number system. You change colors, and you actually grow up. You probably move on to the 3rd grade. Your teacher, hey, Jack, need you pull out paper, buddy, so you can take some notes. Where's your notebook paper? You have a pencil? Guys, so we realize, yeah, the whole system, the counting numbers, they are a part of the whole numbers, but you've become more sophisticated. You know there's more than just whole numbers because the teacher in class said, hey, guys, I make brownies for you, and you thought, oh boy, I'm going to get a whole set of brownies. She says, no, you only get one. You only get a part of it. So the whole system here, I've got to backtrack. I was moving on way too far. You guys weren't that advanced yet. You guys were just moving on to traveling. And what ended up happening, you guys were going to travel. You grew up in Texas most of your life. Johnny, where'd you grow up most of your life? Texas. Probably Texas. And Mason, where'd you grow up most of your life? Yeah, absolutely. So you grew up in Texas, a nice warm state, and you decided, I'm going to go visit some family. And Johnny, I'm not going to ask you again, but you're going to move to Alaska, travel to Alaska to visit family, and it's the winter time. And you brought all your cool summer gear, you spent all your money to travel, and you realize, hey, it is very cold here, and I've just spent all of my money. In fact, it's not 0 degrees, it's below 0. And you realize, hey, I don't have any money to spend to buy new clothes, I've got to borrow some money. So now instead of having no money, you have less than no money because you owe money. You have negative numbers now. And you call these numbers, you call them integers. So this set of numbers, which includes counting and whole numbers, are your integers. What's up, Grayson?
When you're counting the positive, you'll demonstrate.
What's up, bud? Thank you. That's okay. That's okay. I'm going to cross that out. Good catch. 3, 4. Sometimes my brain moves faster than my hand. You're good, man. That's what I would say to you if you make mistakes. We all make mistakes, right? Not a big deal. We lift our shoulders, shrug it off, and say, oh, well, time to move on. So our integers also include, you can see this here, our integers include whole numbers and counting numbers. What's up, bud? Well, I'm changing the colors so you can see that the sets are boxed up, bud. All right. Now you guys are sophisticated enough because you moved back into a nice warm state. You want to eat some warm brownies, and you think you're going to get a whole set. But you realize, no, I don't get a whole set. I only get a part of. So here, I'll just draw in some negative numbers here. You're only getting a part of them. So rather than having a whole set, you get a fraction of a set, or 1/4 or half of the brownie set. So here, we're dealing with fractions because our fractions, what we're really dealing with here are ratios of integers written with the integer in the numerator and an integer in the denominator, as long as the denominator is a non-zero value. Hey, Blaine, can you have 0 in the denominator of a fraction? Not at all. So, therefore, we're dealing with non-zero. If you want it to be we're going to call this type of number a rational number, but that's a good guess. Rational number. So these are our rational numbers, and if you want numbers to be rational, they have got to have a non-zero number in the denominator. Moving on, disconnected from this whole set is a whole other set of wacky numbers, and we call these our irrational numbers. You are a genius, Jack. Thank you, buddy. Keep taking notes, man. Our irrational numbers are numbers such as pi, not the type that you eat. Ha! That's funny. Okay. Or the square root of 3, or let's say the square root of 10. Hey, these are all our irrational numbers. Well, why are they irrational? The reason is because you end up with non-repeating or non-determinating decimals. So the decimals, they're non-repeating, they are non-terminating. Hey, Javier, here's a quick question. If irrational numbers have decimals that are non-repeating or non-terminating, what do rational numbers have to have?
No decimal.
Well, no, they got decimals because we got fractions here. Some fractions create decimals, right? If some fractions create decimals, then take a look up here. It's going to help out. If you're dealing with the irrational numbers, and they have non-repeating, non-terminating decimals, rational numbers have to have what kind of decimals?
Repeating and terminating.
They have to be repeating or terminating. Have to be. All right, cool beans. So what I'm going to do from here is I'm going to put another cool, we'll do a blue box here. Hey guys, actually before I pick blue, give me a cool color.
Purple.
Doing purple. Hey, purple face. Back on track. Doing the purple one. Gonna box this in. And before we move forward, I noticed that I've got to delete one thing. The counting to adding 0 is not a part of our irrational numbers. That was part of what set, Sanjeev? I think I called your name. Sanjeev, hold that thought. Jarrett. Counting numbers plus 0 are what type of set? Here, hold. Absolutely. And now let's fill that back in with our black. Hey, girls, since I let the guys pick the last color, I'm going to let you girls pick this next color, but hold your thoughts. Hold your thoughts. Hold your thoughts. All right. Here's the next valuable piece of information. All of these sets together because guess what, guys? Counting numbers are a subset of whole numbers. Whole numbers are a subset of integers. Integers are a subset of rational numbers. And Hunter, here's my question for you. Are irrational numbers a set of rational numbers? No, these guys are disconnected. So therefore, integers are not a part of irrational numbers. Totally disconnected. You can see with the colors here, they are not connected. All right. Peter, you are next up in line, dude. All right. So all of these sets, Peter, are all of these somehow connected? Let's figure it out real quick, and then I'll let you. Can't say that yet. I haven't showed you the box.
Okay.
Just wait. Hold that thought. Okay. These all make up a set of numbers called our real number system. If numbers are real numbers, they are somewhere within this system. Girls, I promised you earlier, I know that excitement has been building. You girls get to pick the color that I put around everything, the real number system. Pick it. Jules, you're up. Oh, I heard brown. Never mind. Gotta do brown.
Wait, what's the color?
We're doing autumn brown. This is our autumn brown here, guys. All right. All right, here we go. So here's our autumn brown, and now we have got our real number system. Okay, guys, let's move forward from here. Cool. So real numbers, all of these sets are a part of our real number set. But don't take my word for it. Let's actually classify some, and we'll figure out why and how. So let's classify the value that I told you was irrational. I told you this first off, starting out, the square root of 3. So rather than calculating this out, guys, I promise you I cannot do this in my head. Trey, what I want you to do, dude, is take a look here. So I've got the straight line. It's my number line, man. So I got 0 right here. And Trey, what I want you to tell me is what is the square root of 2? Take that back, Trey. Don't tell me the square root of 2. Tell me the square root of 1. Absolutely, it's 1. I'm going to plot it here. And now, Cooper, what I want you to do is tell me what's the square root of 4. Square root of 4 is 2. Guys, check this out. Is the square root of 3 between the square root of 1 and square root of 4? Austin, if the square root of 3 is between the square root of 1 and 4, then what value, what root does it have to be between? What root? What integers? It's between 1 and 2, so therefore you're telling me it's a decimal. Since the square root of 3 is not a perfect square, like the square root of 1 and square root of 4, not perfect square, the square root of 3 is some set of decimals, so therefore, guys, it is an irrational number because it's not a perfect square. Hey guys, if it's an irrational number, Carrie, my next question for you, since it's irrational, what other type of number system can it be? What does irrational fall under? Sure, I mean, those are what make up irrational numbers. But irrational number falls under, it's boxed around something else, a bigger set. What other set could it be a part of?
Real number.
Yeah, it's a real number as well. So it's irrational or it's real. It's real, man. It's real cool. Okay, Abby, head up. Let's move forward from here. Okay, let's look at the number. Abby, you're up. Negative 58.58. And I'll write that down on your paper, and then I will let you solve this. Negative 58.58. We look back up here. Where does it fall under? Mason? Stay focused.
Irrational.
Why is it irrational?
No, it would be.
Huh?
It would be an integer.
Negative 58.8. Hey guys, here's my question. Look up at negative 58.8, Brendan. Is negative 58 is an integer? Does it deal with decimals?
No.
Not at all. What deals with decimals? Rational and irrational numbers. So negative 58.8. Here's my question for you. Is negative 58.8 a repeating decimal? Do the decimals repeat? Are they the same thing over and over?
Yes.
Is 50.58 the same thing over and over? No, it's just 0.5 and 0.8. 0.5 and 8. So therefore, if that's the case, it's terminating because it's rational. It does terminate. 0.58 does terminate. So it's rational. Hey, Abby, we're going to call on Peter. Hey, Peter, what other type of system does rational number fall under?
Oh, real.
So it's also a real number.
Right.
Brendan, you're up, buddy.
But it's negative, correct?
Huh?
Do I get candy for that?
Guys, quick question. That's a great one. He said, hey, this is a negative number. Well, guys, it is a negative number, so Brendan's probably saying, can it be an integer? Do integers deal with decimals? Nope. Only rational numbers deal with decimals, and real numbers deal with decimals, and irrational deal with decimals. And yes, negative numbers can be rational and decimal. Okay? Moving forward. Here's the next one. Hey, Brendan. What is this? Square root of 9 over 3. What's the square root of 9? 3 over 3, which becomes 1. All right. Hunter, heads up. Guys, stand up. Shake your arms out. Stand up. Shake your arms out. Take a deep breath in. When you sit back down, do not slouch, do not close your eyes, and do not bend forward.
Yes, sir.
You guys are sitting up and attentive, ready to learn. Sit back down. Okay, so we have 3 over 3 as a fraction, or 1. Guys, where does 1 fall in our number system? Jules, you're up. 1 falls where? Counting numbers. In fact, guys, I showed you counting numbers, but I will never test you on counting numbers. So you don't have to say counting numbers. You can always start where? So tell me it's whole, then what, Jules? It's real. Wait, slow down. If you don't jump from whole to real, what other systems is 1 a part of? If it's a whole number, it's also an integer, and then it is rational, which means that it is real. Absolutely. So we got all of these values here. So this guy is 1 is a whole number. It's a rational number. Oh, it's an integer first. It's real. Nope. It's rational. And then it is real. Alright, guys. These are what the square root of 9 over 3 is. Let's try another one. Let's do the square root of 10. And in fact, guys, I already told you the square root of 10 is what? Mason, tell me, what type of value is the square root of 10?
Irrational.
Why is it irrational?
Because it does not.
How do you know that? Oh, I told you, but can you take that for a fact? You can only take that as a fact. You don't know it as a fact yet, do you? So guys, let's figure it out. I'm not picking on you, Mason. I'm just saying that. Hey, dude, I cannot calculate the square root of 10 in my head. All right? I only know that through the picture that I drew you above, that the square root, because I said this up here, I said, hey, the square root of 10 is irrational. That's all that I know so far. So let's figure out why it's irrational. Well, guys, let's look at the square root of 9. Oh, don't forget, I got 0 on my number line here. Let's look at the square root of 9. And the square root of 9, you already told us, is 3, Brendan. So the square root of 9 is 3. And let's see, Chance, what's the square root of 16? 4. Okay. So far, I know that the square root of 10 is between the square root of 9 and 16, right? Johnny, take a look at here. What 2 consecutive numbers am I dealing with below as the roots of the square root of 9 and the square root of 16? 3 and 4. So the square root of 10 has got to be between 3 and 4. Yes. So far, since you know the square root of 9 is a perfect square, which becomes 3, the square root of 16 is a perfect square, it becomes 4, then you know that there's no number in between 3 and 4 that makes a perfect square, that's a root of, there's no integer between 3 and 4 that makes a perfect square. So therefore, square root of 10 is not a perfect square. If that's the case, square root of 10, it's got to be 3 point something, right? It's a decimal. It's not a perfect square. It's a decimal. And if it's not a perfect square, then it is, you already told me this part, Johnny. Say it out loud. Irrational. So Robert, crazy, Robert. If it's irrational, it means what? Decimals are? They're not incorrect. What are the decimals doing? Look up here, man. Or? Yeah, guys, and I already told you, I cannot calculate this. I do not know how to do it in my head. But let's prove it with a calculator here. Let's throw on a handy calculator. Now what I'm going to say here, let's look at square root of 10. Look at this, guys. Do you see a whole set of repeating numbers across the screen as decimals? Is one repeating over and over and over? Nope. Those don't count. It's got to be 1, 1, 1, 1, 1, right? Not repeating. And since the screen has filled up, it's basically run out of room to put more decimals. We know that it's a non-terminating decimal. Therefore, guys, you have a visual that it's an irrational number. It takes up too much space. It would do that and it would fill it up, and the RAM would fill up so much that the computer would probably crash and you have to restart it. Silly stuff, right? It doesn't have enough memory to keep functioning. It saves speed. It saves the speed and doesn't make it have to repeat. Does that make sense? You good? If they didn't have a kill switch to say, hey, only show 10 problems. If it didn't have a kill switch like that, after 10 problems stopped, if it didn't have a kill switch, what would keep happening? Keep going and keep going. And what would happen to the computer? If the decimals don't terminate, what would happen? The computer would keep spitting out numbers until it either, 1, got tired and ran out of battery, or 2, overloaded its memory and made it crash.
What if you send a lot of random?
Man, I'd be impressed. You do that, I'd be impressed. Okay. Texas Instruments probably does. Honestly, this is a Texas Instruments tool. So they probably do. Travis's Instruments, probably not as well. So let's keep on going. All right. Let's see. Our next problem we're going to deal with is 3 over 0. And let's see here. Zoe, what's 3 over 0? Well, let's think about that. Let's write it in long division here. How many times do you have to multiply 0 to get to 3? Hunter, head up, bud.
You can't. Tired.
You can't. So therefore, this is not a real number.
False.
It's not a real number. And hey, where does not a real number, or where does 3 over 0 land in our number system?
Nowhere.
Why not?
Because it's not real.
Wait, I just heard that it's irrational. Does 3 over 0 create a decimal that does not repeat or terminate? No. So therefore, it's not a part of the irrational system. It's not a part of the rational system. You already told me you can't solve it. It's not a real number. Therefore, it's not even in the system is what you're telling me, Trey. You're telling me, hey, this does not fit in this system. Okay, moving on.
Question.
What's up, Jack?
What would happen if you actually put like 3 divided by 0 in the calculator?
3 divided by 0? I don't know. Let's find out, dude. That's a great question.
No, don't do it on your computer. It might crash.
I hope it doesn't. You just trying to crash my computer?
No, use the calculator.
No, we're going to do this right now. Guys, Jack asked a cool question. We're going to find out what would happen on my calculator if I typed it in here. Let's do 3, look, divided by, I'm going to wait till it's silent, Mason. Let's enter here. Error, divided by 0. Quit or go to. Let's just quit. There we go. Let's find out what happens when I do go to. Let's what happens when I go to. Enter. So what does 2 tell me to do? Let's do 2. Nope. Just goes back to the same spot. Nope. We're good. We're moving forward from here. Moving forward. All right. So now the one we got 2 more to go through here, guys. The square root of 1 over 4. Square root of 1 over 4. Everybody stand up, shake your arms out. Shake your arms out, shake your legs out. Take a deep breath in. Okay, have a seat. Have a seat. Leo, what's the square root of 1? Square root of 1? What do you have to multiply by itself to get to 1? Yeah, so therefore the square root of 1 is 1 over the square root of 4, Leo. Square root of 4. Huh? So the square root of 1 over 4 is 1 half. Because 1 half times 1 half equals 1/4. 1 half also equals 0.5. So 1 half equals 0.5. Let's scroll up. 1 half equals 0.5. Therefore, Nick, 1 half is what type of problem? Why is it rational? I showed you 1 half right here, but why is it rational? It's a fraction, 1. That's one answer. Another answer, Irish, is what?
Yeah.
0.5 is what kind of decimal? Non-repeating or is it repeating? Is 0.5 repeating? It's non-repeating, but here's my next question. Is it terminated or not terminated?
Not terminated.
So if it's not terminated, 0.5 is a rational number.
Yeah.
Okay? The rational number. All right. We got 0.5 as if it's rational, Iris. Grayson, what else is it if it's rational? Yeah, it's rational, it's not repeating, not terminating. If it falls under this system, what other system does it fall in?
Irrational.
Are these two connected? No, you can see they're broken. What does rational fall under? What else is it wrapped into? Check this out. A whole number is wrapped around an integer because it's a part of the integer set. An integer is wrapped around a rational number because it's wrapped around the integer set. Rational number is what? Rational number is not a whole number exactly. 0.5, is 0.5 a part of this whole number set? No. Is 0.5 a part of an integer? No. Is 0.5 a part of a rational number? Yeah. Is 0.5 a part of an irrational? Is it repeating or non-terminating? Nope. Therefore, this says non-terminating, right? Does 0.5 terminate? It stops after 0.5, right?
Yeah.
So therefore, it's not rational. It's not irrational. It's rational. 0.5 is rational, and it is also what? Has to be a real number. So it's rational, and it's real. Last one, guys, and then you get to get your homework. It is, let's do, and Gabby, you're up. Square root of negative 17.
Well. Like, am I supposed to do the thing where you...
Yeah, tell me where does square root of negative 16 fall under?
Oh, okay. Negative 6 would be negative 4.
Okay, so wait, time out, guys. Let her solve this.
Wait, I'm 4.
Negative 16. We'll say 4. Okay.
35.
If the square root of negative 25 is 5. Don't write this down, guys. It's a trick. And I'll tell you why in a second. Gabby, how do I multiply 4 by itself to get negative 16? What number times itself equals negative 16? 4 times 4 equals 16, right? That's a negative number on the inside of the square root. You can't do that. It has to be a number times itself. Negative times negative. Positive times positive. Huh? You what? What did you say? You can't. So therefore, any negative number inside of the square root sign it's not a real number. So it's not a part of the real number system. Guys in the front rows, people in the front rows, grab a sheet of paper at the front desk for each of your students. Javier, can you bring me my whiteboard and the 2 pieces of candy up there? Not my whiteboard, my iPad. It's up on that table. There's 2 pieces of candy and an iPad.
Candy and iPod.
Yep. Hey, Jack, come here, dude. What's up, man? Thank you, sir. I'll give you some. Here you go. Start your homework.
I was like this. I don't know. It just sounded annoying. No, it's central right now.
I do know. Except one.
But if you do that in the class and everybody else is how are your notes? Can I see your notes?
I know that.
Being rational and irrational numbers, how to tell if the number is not real.
Oh, that's
When I suggested putting 3 divided by 2 in the calculator, I just wanted to see it crash. I didn't want it to crash. It's just
guys, you should be working quietly. For now, I'll throw the set of numbers up on the screen so you can look up if you need it. Guys, I'm going to ask a couple questions and then I'll let y'all get on with this. What's up, Johnny? If it's a negative fraction, you have to solve the fraction. Because if it's a non-repeating decimal, if it's non-repeating and non-terminating, guess what? It's irrational if it's non-repeating, non-terminating. But if the fraction is, if it ends up being something like, what if it's 3 over 3? That's 1, right? That's rational. What if it's 1/2? Because the decimal terminates, then it is what? And I put 2/3 as a rational number. I made a mistake here. 2/3, that's point what? It's repeating. That making sense? judging either way. It's okay. Hold your hands up. Lower your hands. Here's the next. Who's kind of in the middle? It's like, well, you know, I didn't dislike it, I didn't like it. It's okay. Yeah. It's just you give me my information, I'll take it. Okay, fair enough. Lower your hands. We got a test on Friday. Who feels that they are going to ace this test on Friday? Okay, lower your hands. Who still has a little bit of confusion over some of the sections? Keep your hands up. Okay, lower your hands. Alright guys, lift your heads. We got a test on Friday. Here's the deal. Those of you who feel confused on today's lesson, oh, you guys, I got one more question. One more question. Lower your head, Peter. Close your eyes, buddy. Johnny, down. Here's the question. Who does not know how to get on the School Fusion and look on the website on School Fusion? Okay. Those of you who just raised your hand, mark your hand. It's your responsibility to come into my class at lunch today, and I'll help you find out how to do that. Because, lower your hands. Because today, if you're confused about today's lesson, what I'm going to do is post a video of what we learned in class today on School Fusion. You can go there and find out about today's lesson and what we went over in class. Watch this video. Guys, have a great day. Good luck. Do it the way. Do it the Wildcat way. Quick, or help. All you have to do is write it out. Hey. Well, how do you know he's gonna win? Hold your thoughts on this conversation. What? At you, two, and your friends? Do you see how you handled it? What kind of, how that happened? How did that work out? The way you handled it, you poked him with a pencil. How did that help you out? You can look at it that way, sure. But what happened in the process? Did you get talked about in person? Did you keep the pleased with your action? But basically, you didn't really get a seat to help you out. You were moved because you were, the way I looked at it, being an associate and a teammate. So you gotta learn to communicate. Communicating without poking his head. Communicating who you want. Because does Jack know that you bought him the way that he bought you? Probably not. He probably thinks you poked him in his green back. But if you were to say, hey Jack, you know, that kind of bothers me, he might say, oh, I'll stop. He's a smart guy. I guarantee he'll stop people. Try to head up. What's up? Come into lunch. Come into lunch. This is your lunch, stay right here. fourth period? I don't have a class right now? Well, I'm not sure you want to know.
But I think I know how. Is it like the web page and then you click and then you go to the fusion page? I'm just wondering, cause, like, I think I know how to do it. I'm just making sure that I know what, I'm thinking of the right thing.
Let's go over there.